All right, guys, here's your solving rational equations video notes. We've been doing solving rational expressions. So today we're going to take two rational expressions and set those equal to each other, and that is going to be an equation that I think we can solve, right? So in this first one, we need to FOIL both the left and the right sides. And when I do that, that's going to give me, let's see, 2y squared minus 2y plus y, minus 1, equals, on the other side, 2y squared minus 5y plus 10y minus 25, all right? Also, be sure you're writing these notes down if you need them, okay? As we do this, you might have to pause the video if I'm going too fast or speed up if I'm going too slow. All right, those are going to combine over on the left side to give me 2y squared minus y minus 1 equals, and over here I can combine these y's to be 2y squared plus 5y minus 25. All right, and then I'm seeing right away that I have a 2y squared here and here, so if I were to subtract that over, they're just going to cancel, leaving me with negative y minus 1 equals 5y minus 25. All right, I'm going to add y on both sides as well as add 25. And I think that's going to cancel the y's over here, leaving me with 24 equals, on the other side, 6y. And then the 25s would cancel. If I divide both sides by 6, then 4 equals y. All right, number 2 says x times the quantity 2x minus 3. And so I need to distribute that in to get 2x squared minus 3x. And then again, FOIL this other side. So give me 2x squared. Let's see, minus 8x plus x minus 4. I can combine those to give me 2x squared minus 7x minus 4. Bring down my other side, 2x squared minus 3x. Okay, again, kind of like our last one, this has another 2x squared on both sides, so if I subtract those over, they're going to cancel, which means I probably just need to add 7x over here and over here, and that will leave me with 4x equals negative 4, so of course x equals negative 1. All right, moving on here to number 3. So here is where these get a little trickier. We have some steps on the side. We first need to find our least common denominator, multiply the whole expression by the common denominator, and then solve for the variable, and then finally check our answer. There are going to be some that have extraneous solutions, so we have to check our answer by plugging it back in, making sure that our denominator isn't one of those solutions. Otherwise, we would be dividing by 0, and that is not good. Okay, so if I look at number 3, this says 2 over y plus 4 over y equals 3. So right away I can make this 6 over y, those are the common denominator, equals 3. And you could say this is like 3 over 1. So to get a common denominator, or least common denominator, I need to multiply by y. All right, I would multiply this side by y over y to give me a common denominator of y. Right? If I simplify this, I'm going to write it down here. This will be still 6 over y on the left side. On the right side, 3y over y. And so now, once your denominators are the same, you can essentially cross them out and just take the top. The top here says 6 equals 3y and solve like that. Okay, if I divide both sides by 3, y of course equals 2. So it's kind of nice. Once you have common denominators on both sides of your equal sign, again, you can cross those out right here and just work with the numerator. All right, number 4, let's try to do the same thing. Number 4 says, we're going to skip this problem, by the way. Number 4 says 3 over 7 plus 8 over x equals 1. All right, so this one has a couple things we need to do. You can see we have a 7x as our common denominator because this would be like over 1 right now. And so if I think of it like that, I know that this term right here is missing a 7. So I'm going to multiply by 7 over 7. And then the 1, if it's currently 1 over 1, it's missing both the 7 and the x. So I have to take it times 7x over 7x. And then, of course, the 7 out front is missing the x. This is going to be multiplied by x over x. Okay, so if I rewrite this, this is now 3x over 7x plus 8 times 7 is 56 over 7x. And then equals, well, 1 over 1 times 7x over 7x is just 7x over 7x. Again, once my denominators are all the same, you can cross those out and just work with the top, giving me 3x plus 56 equals 7x. All right, I'm going to move my 3x over by subtracting it, giving me 56 equals 4x. If I divide by 4, let's see, 4 goes into 56, goes into 40 10 times, and another 16, so that's 14 equals x. All right, 14 equals x. Again, we're skipping this problem and going here to number 5 on this page. Number 5 says 4 over 2x equals 5 over x plus 6. Okay, so when you have problems like this where it's just it's only one fraction equals another fraction, this is called a proportion, right? And we solve proportions by using cross multiplication. So over here, I'm just going to cross multiply the top left to the bottom right and the top right to the bottom left. I've been doing proportions for a while. So this would leave me with, I'll write it out all at once here on this first one here, 4 times the quantity x plus 6 equals, and then going this way, you can either do 2x times 5 or 5 times 2x. Does not matter. Multiplication is commutative. Okay, if I distribute in the 4, this is going to give me 4x plus 24 equals, and this side is just going to be 10x. So I better subtract the 4x over. And I'll come over here. This is going to be 24 on the left side equals 6x. Divide both sides by 6 to get 4 equals x. All right, moving right along, we have number 6 down here. X minus 3 over x plus 5 equals x over x plus 2. Again, cross multiply. I'm going to write these out just side by side to start with for the top left times the bottom right. So just x minus 3 times the quantity x plus 2. We'll FOIL that here in a second. And then for the other one, whenever you have a monomial, 1 term, times a binomial, 2 terms, put the monomial out front and your binomial in parentheses. It makes it a little easier to distribute when we go to distribute this later. However, we do need to FOIL this side to be x squared. Let's see, x squared plus 2x minus 3x minus 6. And then equals, like I said, if we just distribute on this side, x squared plus 5x. All right, I can combine those really quick on this one to be 2x, how about x squared plus 2x minus 3x is a negative x minus 6 equals x squared plus 5x. All right, and let me extend this page. Okay, so what's going on here? I have an x squared on both sides, kind of like those first couple problems we did. If I were to subtract this over, those are just going to cancel. And then I have a negative x over here and a positive 5x. It's usually easier to move your smallest x, or smallest variable, whatever that is. Because when you do that, you're going to end up with a positive on the other side. If I were to move the 5x over, that would have given me a negative, and also both terms would be on the same side. It just would leave me with more steps. So move your smallest one, usually. That gives you the easiest way to find your answer. In this case, x, of course, equals negative 1. All right, one more problem here for you before we end our notes together, and that is this one. This one says x over x minus 3 plus 6 equals 3 over x minus 3. Okay, so this is a kind of a combination of the first few that we did. Right now I have an x minus 3. This is an x minus 3. If I were to put the 6 over a denominator, its denominator would currently be 1. And so it needs to be multiplied by x minus 3 times x minus 3, or over x minus 3. And so let me rewrite that a little bit better here. I have x over x minus 3 for my first one, plus, so now this is going to be 6 times x minus 3 on top over x minus 3 on the bottom. And then this is going to all equal 3 over x minus 3. All right, now notice that my denominators are all the same. So just like before, once I have those all the same, I can essentially eliminate those and just work with the top, leaving me with x plus, if I distribute this 6 in, this is 6x minus 18 equals 3. Okay, x plus 6x is 7x, and then minus 18 equals 3. If I add 18 over, Now I have 7x equals 21. Divide both sides by 7, and it really looks like our answer is going to be 3, but that is not right. Our answer is not 3, because if I were to plug this back in to my original, I am noticing that my denominator is x minus 3. Okay? I cannot divide by 0. And so if I have my current answer, which is x equals 3, and I plug this in, 3 minus 3 is 0, then to start with, I would be dividing by 0. Okay, so I have to check for extraneous solutions here. 3 is an extraneous solution. That is not good. Therefore, this is not 3. It's actually no solution. No solution for this one. And we should have been checking that all along. If I go back and look at some of these, you can see 4. That would not make any of those 0 for this one. What was my answer for number 6? It was -1. -1 would not make any of those denominators 0. That's fine. Again, going back a little farther here, we got y equals 2. Again, I'd be just dividing by 2, not 0. And this one was a 14. Again, that would not make any of those 0 there. Okay, so be sure you are checking. I waited to check to the last one because I knew that one was not going to work. The other ones, however, do all work, but you might get something that looks like an answer that's not. It is no solution. All right, guys, those are your video notes for today. Be sure you get those all written down, and then your assignment I'll probably have for you in class.